Hey guys, Rob here. Going to take a look at the geometric construction of a line segment that's exactly √3 units in length. So let's get into it. So first of all, let's grab the weapons of maths construction, straight edge, compass. So in this construction, I'm given a line segment that's exactly 1 unit in length, and I'm asked to use that as the basis for creating a line segment that's exactly √3 units in length. And there's a couple of ways of doing this construction, but essentially they all involve constructing a version of this triangle here. So this is one of the set squares that's present in any standard geometry set, and it's a right angle triangle where the longest side, the hypotenuse of the triangle, is double the length of the shortest side, this one here. So if the shortest side of the triangle is 1 unit in length, it means the hypotenuse, the longest side of the triangle, is 2 units in length. And if you then apply Pythagoras' theorem to this triangle, if the hypotenuse is 2 and the shortest side is 1, you'll discover that the middle third side is exactly √3 units in length. So essentially, if I was to construct a right angle triangle where the hypotenuse, the longest side, the side opposite the right angle, is double the length of the shortest side, then the middle third side will be exactly √3 units in length. So the plan here is to construct an accurate version of this triangle here. So to do this construction, I want to take this line segment here, which is 1 unit in length, and I first of all want to extend it. I want to make it a bit longer. So to do that, I'll just bring in my straight edge, place it down carefully along the line segment that's given, and then just use my pencil to extend it, to make the line segment longer, like that. So what I need to do now is I want to mark a point on this extended piece of the line segment here that's the same distance from this end of the original line segment as the other end is. In other words, go this distance again here out the other side of that point there. And to do that, I'm going to use my compass. So if I bring in my compass and just very carefully place the point of the compass on one end of the line segment, like that, and the pencil, so it's touching the other end of the line segment, okay? And then just place the compass here and draw an arc all the way around like that. Now, you can see this point here is now the same distance from that point as this one is. So to get a right angle now coming through this point here, a perpendicular line coming up here through this point here, I'm just going to do my perpendicular bisector construction on the line segment that goes from here to here. So again, to do that, I'll just bring in my compass. So if I place the point of my compass on one end of the line segment like this, just again, carefully do that. And stretch the pencil out so it's more than half the length of the line segment, like that. And then draw your arc. And then without adjusting the radius of the compass, move the point of the compass to the other end of the line segment here. Again, carefully. And draw an arc. So now, if I join this point here to this point here, I'll have a perpendicular line coming through this point here, which is exactly what I'm looking for. So I'll bring in my straight edge again. Just line this point here up that way and draw the line. So I've now got a perpendicular line coming through this point here, and there's the beginning of my right angle triangle. So remember, we were told that this was 1 unit in length. I'm trying to find a point now on this line here that's 2 units away from here. Because if I do that, if I can find a point that's 2 units away from this point here on that line there, that will be my right angle triangle, where the shortest side is 1 unit, the hypotenuse is 2 units, and the middle third side here will be the √3 units I'm looking for. So to do that, I'm going to use my compass again. Because remember, I can set my compass to 2 units very easily by going from this point here to the end of the original line segment. Remember, that's double the length like that. So there we go, stretch the pencil out till it's touching here. And if I put the point of my compass on this end point here and just mark an arc up here, there we go. So that point there is 2 units away from this point here. So if I was to join those two together, I don't really need to do this for the purpose of the construction, but just to illustrate the point, if I join those 2 points together, there's the set square triangle I've been attempting to construct. This side here is 1 unit long, that's a right angle there, and this side here is 2 units long, which means this middle third side here is √3. So I'll just draw that side a little heavier, as that's the final answer. That's the line segment I was asked to construct. I'll just draw that segment in. Very clearly label that. That side there is √3. So that's the construction of a line segment that's exactly √3 units in length. As always, if you have any questions, send me a message.